All right, welcome to day one of your ratio and proportions review for your EOG. Number one from your warm-up. Again, today will be a warm-up, a quick video lesson, and then a review bit.ly. So, John has spent $12.50 at Walmart. He bought a notebook for $2.25 and some packs of pencils for $1.50 each. How many packs of pencils did John buy? Well, a couple things in this problem. They are telling me a total. That's really important. Once I know the total, I know it's an algebra problem. They bought a notebook for $2.25. We bought some pens for $1.50 each, and we want to see how many pens did we buy. Well, we don't know that. First thing I would do is start setting this up as an equation problem. Again, we know that it's $12.50, but that's our total. We represent a total with an equal sign. It's an equation. We know that he bought $1.50 worth of pens, but we don't know how many pens, so I use the variable P as a placeholder until I figure that out. We know in addition to pens, he bought a notebook, so the equation that we need to solve is $12.50 is the same as $1.50 times the pens plus $12 or $2.25. Now, some people might think through this problem logically instead of algebraically. You should be attacking the problem in the same way, though. First thing, we need to get rid of the how much the notebook was. So again, I took the total, I subtracted the notebook. Did it to both sides in my equation. I now know that he spent $10.25 on pens. But I know how much one pen is, and I want to see how many pens did he buy. So $10.25 divided by $1.50, we'd find out that he bought approximately 6 pens. You end up getting a decimal answer, but he didn't have enough money for 7, so 6 point something. We need to round that down because he has enough money to buy 6. He did not have enough money to buy 7. Number 2, this is what we're going to be working on a lot today and all this week are some ticket problems. A printing press works for 8 hours. The printing press can produce 1/2 of a book in 1/4 of an hour. We want to see how many books. We don't know. The printing press can make in an 8-hour day. Well, again, they said 8 hours twice, so I'm going to cross one of them out because this first one's just setting up a scenario. It's being a description of the problem. But it's not two different 8 hours. They're the same 8 hours. So again, I'm only going to use it one time in my problem. To start this problem, the two numbers in the same sentence, they build your ticket, they are your given ratio. So again, I'm comparing books to hours. I know that he can do 1/2 of a book in 1/4 of an hour. As I keep reading, I see 8-hour day. So again, I know how many hours it is, but I don't know how many books. So once we have the problem set up, this is where we got to use some strategies to help us out a little bit without the use of a calculator. 1/4 times x is 1/4 x. 1/2 times 8. Well, this is really 8 over 1. So again, off to the side, I showed how to do the multiplication part. Again, we cross multiply here, but when we have a fraction times a fraction, it's numerator times numerator, denominator times denominator. 1 times 8 is 8. 2 times 1 is 2. Again, some people might see that reduces easily to 4, but since I don't have the use of a calculator on this problem, I'm just going to leave it alone. From there, I'm isolating x by dividing by each side by 1/4. 1/4 x divided by 1/4 is 1x. 8 over 2 divided by 1/4. Again, we write out the division problem. Top divided by the bottom. Top divided by the bottom. And then we keep change flip. Keep 8 over 2. Division becomes multiplication. 1 over 4 becomes, 4 over 1. If I can get my eraser to work, there we go. Becomes 4 over 1. 8 times 4 is 32. 2 times 1 is 2. So we really have 32 over 2, perfectly acceptable answer, or 32 divided by 2 is 16. So x was really 16. Number 3, angle A and angle B are complementary. Well, right there, I'm going to stop there, and I know that these two angles make complementary corners, 90-degree angles. Angle A is 2n minus 20. Angle B measures 10 degrees. What is the value of n? So the first thing I would have done in this problem was drawn a picture. A picture would have really helped you. Remember, complementaries make those corner boxes. I know that it's angle A and angle B, so I labeled them. Angle A, 2n minus 20. Angle B, positive 10. From there, I know together they make a 90-degree angle. So I could say that angle A, 2n minus 20, plus 10 equals 90. Probably the most common mistake in this problem is that we're not combining like terms carefully with a calculator. This is negative 20 plus 10, which makes negative 10. So the real two-step equation you should be solving is 2 times n minus 10 equals 90. From there, we add 10 to both sides. 2 times n now is equal to 100. I said times 2, so I divided each side by 2. 100 divided by 2 is 50. Now, to check your work, real easy. We know that this angle is 10 degrees. We know that for them to equal 90 degrees, this should be 80 degrees. Well, if n is worth 50, then this angle should be an 80-degree angle. 2 times n, 2 times 50 is 100. 100 minus 20 is 80, and 80 degrees plus 10 degrees is a 90-degree corner angle. Thumbs up, yes, absolutely. Always can check work in geometry algebra problems. Number 4, okay. Not that difficult a problem. People usually get a little overwhelmed here, but again, you know what shapes are there, and you definitely know how to find the area of each shape. And then we could think about, well, what's going on in this problem for it to answer the shaded region? Because at the end, I only want to know what the blue part is worth, not the entire thing. The first thing you should be doing in a problem, a complex composite figure, is breaking the shapes apart. I know that I see two things here. I see a circle and I see a square. And I know it's a square because they only gave me one dimension. They would have to give me the length and the width if it was a rectangle. Well, this line goes all the way through the circle. So clearly they are giving me a diameter in my circle of 5. Again, radius is half as big, half of 5, 2.5. I know this is an area problem, so before I even go any further, I'm just going to cancel out the denominator and just look at the radius. Well, I'll get to the square after I solve for the circle. First up, got to know your formulas. Area of a circle is equal to pi times its radius to the second power, or pi radius squared. I have my radius waiting for me, so I just dropped it into my equation. Pi times 2.5 to the second power is approximately 19.6. I always like to keep one decimal in circle problems. That's the area of just the circle. So if this was just a circle, 19.6, we're done, we move on. But that's just the amount of area that's being taken out of that square. I still have to find the area of the square to see how much total area there was to begin with. Well, again, this line goes all the way through my square. So that's got to be the length or the width. 5 is the length, 5 is the width because it's a square. How do you find the area of a square? Length times width. 5 times 5 is 25. So now I have both my area. Area of my square, area of my circle. This started off as a square, and now they've taken some area out of it. They punched a hole, they cut it out, it's gone, it's come out of the square. So the last step, I got to take the area of the square and subtract the area of the circle, and you should get a final answer of about 5.4. If your decimals are off, that's okay. It just probably depends on how you did your circle, whether you use pi or 3.14, and how many decimals have you really kept. So as long as your answer is around 5.5, 5.4, 5 point something, you have a correct answer. All right, today and every day this week, we're going to be doing a daily dose of algebra. Last week, we did the easy two-step equations. This week, we're going to take care of some of those complex two-step equations. They're really not hard because if you know how to break them apart and set them up correctly, we end up doing the same exact thing, and you have the use of a calculator to take care of your fractions for you. So first off, we have to be able to read correctly. 4 times x plus 12 is all over 3, but I'm not going to use this over word. I'm going to think about a fraction bar is really a division symbol, so the real problem is 4 times x plus 12, all being divided by 3 is the same as 10. The first thing, you've got to break these problems up and set them up correctly. Remember, everything is being divided by 3. Everything is over 3. So this is really 4/3, 4 over 3, times x, plus, I'm keeping this symbol because it's the only symbol in the problem, 12 over 3. That just lets me know that this is a positive 12/3. If you could break these apart, from there, we are solving them the exact same way we solve all equations. Now, some people may put these in a calculator and reduce them down. 4 over 3 is really 1 1/3. 12 over 3 is really positive 4. But if you want to just leave them as is and deal with fractions, again, you have the use of a calculator, so it should not be that difficult. From there, the first thing you're doing is subtracting 12 over 3, because that's the opposite of plus 12 over 3. Remember, golden rule, whatever I do to one side of an equation, I do the exact same to the other. 10 minus 12 over 3 is 6. So now I have 4/3 times x equals 6. Well, I said times 4/3. The only other thing I have to do here is divide by 4/3. 6 divided by 4/3 in a calculator is going to say 4 1/2. Now, again, just like all algebra problems, I can take my answer and plug it back in to check my work. I'll show you that now. In green here, the real problem was 4 times x. Well, now I know x is worth 4 1/2. So it's 4 times 4 1/2 plus 12. All being divided by 3. But you can set this up in your calculator exactly how you see it using that BC button. 4 times 4 1/2 plus 12 all over 3. You press enter on a calculator. If you put it in correctly, you're going to see positive 10 pop up. Positive 10 is the same as positive 10. 4 1/2 has to be the solution to this problem. Always checking your work in algebra. You should always know if you're right or wrong. Again, I'll leave that up so you can see it. Make sure you pause the video as I went through if you need to take notes on it. All right, today we're going to be doing a lot of ticket problems this week. Some with calculators, some without. Today and tomorrow, no calculator. So the first thing we need to make sure we remember how to do is how do I divide fractions? Most people learn keep, change, flip. If you learn same, change, opposite, keep, flip, change. There's a bunch of different ways to remember it, so use your strategy. Remember, we always keep the first fraction. So if I have 3/4 divided by 2/5, I'm going to keep 3/4. 3 over 4. Division becomes multiplication. And I flip the reciprocal of my fraction. So 2 over 5 really becomes 5 over 2. We're going to multiply across the top and across the bottom. Numerator times numerator. Denominator times denominator. 3 times 5 is 15. 4 times 2 is 8. 15 over 8. Second one. Now, mixed number divided by mixed number. If we have a calculator, easy, we can input those, but without a calculator, first thing you got to do is convert this problem to improper fractions. Remember, we take the whole number, we multiply times the denominator, we add in the numerator, we keep the denominator the same. So I already know that if I'm converting this from 6 1/2, it's something over 2. 6 times 2 is 12. Plus 1 is 13. So 6 times 2 plus the 1, 13 over 2. Divided by 2 times 3 is 6, plus 1 is 7. So 2 1/3 is really 7 over 3. Once you have it set up, keep it, change it, flip it. Now, when you have to multiply, don't be afraid to show the work off to the side. 13 over times 3. 3 times 3 is 9. 3 times 1 is 3. So 13 times 3 is really 39. 2 times 7 is 14. We can go ahead and leave our answer as 39 over 14. So again, keep, change, flip. Whatever your strategy is, you need one to be able to do these without a calculator. All right, moving on to today's examples. We have 2 examples, and we're going to leave all answers as improper. I actually reduced them on the board just in case, just to show you that, hey, some of these are actually pretty easy to reduce, and they might ask you to do something like that on an EOG. First up, we're going to read the problem. If 1/2 gallons of paint covers 1/6 of a wall, how much paint is needed for an entire wall? The first thing we should see is what is our given ticket and ratio. Remember, those 2 things are found in the same sentence together. They are together for a reason. 1/2 gallons of paint, 1/6 of a wall. First off, there's my ticket. Gallons of paint, walls. My ticket explains the numbers. So this is 1/2 gallons of paint. This is 1/6 of a wall. Gallons of paint compared to walls. The 2 numbers that are together in the same sentence, 1/2 over 1/6. Gallons of paint, amount of wall. From there, in this problem, there's no third number, but they talk about an entire wall. Well, if I was going to paint this entire wall, I'd be talking about 1 wall out of the 4 in my room. Well, I don't know how many gallons of paint, but I know that it's 1 wall, and this is the whole reason for the ticket. Where can I put that entire wall? Well, I have my walls in my denominator, so that 1 entire wall goes in my denominator. If they were talking about 1 gallon of paint, I'd put that 1 over X. So again, reading carefully, using your ticket to set up your problem. From there, we're cross-multiplying, solving for our variable. 1/6 times x is 1/6x. 1/2 times 1 is 1/2. I'm isolating x by dividing by my coefficient. One side cancels out. The other side, top divided by bottom. So 1/2 divided by 1/6. Keep, change, flip. 1 times 6 is 6. 2 times 1 is 2. 6 over 2. Now, if it's a gridded response answer, I would leave it alone. 6/2. If it's multiple choice and it's something easy to reduce like that, 6 divided by 2 is 3. So either answer you could see A, B, C, D, but a gridded response, I would go ahead and just leave it as 6 over 2 and move on about your day to the next problem. Again, ticket. Build out your proportion. Use the given ratio. Same number, same sentence. Get stacked together. Figure out where does the third number go. Numerator or denominator. Put a variable in the missing spot. Cross multiply. Keep, change, flip. Easy stuff. Second example. John is working for 4 hours at his job. He is able to mow 3/4 of an acre in 1/3 of an hour. How many acres will he be able to mow after working for 4 hours? Well, this 4 hours is all by itself in a sentence. So that's not where I'm going to start. Remember, I always want to start with the two numbers that are in the same sentence together. Right here. 3/4 of an acre in 1/3 of an hour. That is my ticket. That is my given ratio. That's where I start the problem. And then it says, just like the warm-up, they repeat some information. How many acres? We don't know, but he's working for 4 hours. So these two 4 hours are the same 4 hours. I'm not going to use it twice in my problem because it's the same information, just repeated. Again, acres to hours is my ticket because they're in the same sentence and they describe the numbers in that sentence. The numbers that are together, 3/4 of an acre, 1/3 of an hour. Again, using my ticket to build out my problem. From there, for what? 4 hours. I have my hours in my denominator and we don't know how many acres that would be, so that's why I'm using x. Again, I just made 4 an improper fraction. All whole numbers over 1 makes the improper fraction version. From there, cross multiply. 1/3 times x, 1/3 x. 3/4 times 4. This I would show off to the side because it's very easy to make mistakes. When we're multiplying fractions, across the top, across the bottom. 3 times 4 is 12. 4 times 1 is 4. So 3/4 times 4 over 1 is 12 over 4. Again, I'm isolating x by dividing each side by 1/3. One side cancels out. The other side is my division problem. Top divided by bottom. 12/4 divided by 1/3. We keep it. We change it. We flip it. 12 times 3 is 36. 4 times 1 is 4. Again, you could leave your answer as 36 over 4. But since 36 divided by 4 is really 9. Again, easy mathematical computation may be asked if it's multiple choice. If it's gridded response, 36/4, move on. So again, tickets, same number, same sentence, build out your proportion, cross multiply, isolate x, divide by your coefficient, keep, change, flip, you have answers. Again, keep your work nice, neat, organized, have a workspace to be able to do your computations off to the side. At this point, I would pause the video and try these next 3 on your own. When you're ready, unpause the video and I will go over them with you. All right, first one. Betty uses 4.5 cups of sugar to make 6 pies. Boom, 2 numbers, same sentence. How many cups of sugar? I don't know, for 1 pie. So again, cups of sugar is being compared to pies. I know that because cups of sugar describes 4.5, and he's making pies, which describes the 6. 4 1/2 over 6. Again, 4 times 2 is 8, plus 1 is 9, so 9 over 2 over 6, 6 over 1. I have all my improper fractions. I'm ready to continue with the problem. The only number that's by itself is the number 1. I think to myself, 1 what? Well, it says 1 pie. My pies are on the bottom, so that's where I put the 1. I don't know how many cups of sugar, representing that with a variable. From there, we cross multiply. 6 times x, 6x. 9 over 2 times 1, 9 over 2. Again, I'm isolating x by dividing by my coefficient. Each side is getting divided by 6 over 1. One side cancels out. The other side is my division problem. top divided by bottom, 9 over 2 divided by 6 over 1. Keep, change, flip. 9 times 1 is 9, 2 times 6 is 12. You can go ahead and just say x equals 9 over 12. It does reduce to 3/4, but more than likely we'll just leave it alone as 9 over 12. So again, taking your time, keeping your work nice, neat, organized. Second one from this slide. If 1/2 gallons of paint is needed to cover 1/3 of a wall, right there, again, 2 numbers, same sentence, given ratio and my ticket. How much paint, we don't know, is needed to cover a wall. Well, again, they didn't give me a third number, but they said a wall, one wall, not walls, plural. They would have to tell me how many walls that would be. A wall, assume that this is one wall. Well, again, I'm going to start with a ticket. Gallons of paint to walls. I know that's what we're comparing. Gallons of paint to how much of a wall? The 2 numbers in the same sentence get stacked together. 1/2 over 1/3. 1/2 gallons of paint, 1/3 of a wall. Again, I identified that this is a unit rate problem because it's talking about a wall, one wall. We know that it's one wall, but we don't know how many gallons of paint. That's my variable. From there, again, we cross multiply. 1/3 times x, 1/3 x, 1/2 times 1, 1/2. Dividing each side by 1/3. One side cancels out. The other side, 1/2 divided by 1/3. Keep it. Change it, flip it. 1 times 3 is 3. 2 times 1 is 2. 3 over 2, yes, it reduces to 1 1/2, but I would just leave it alone as 3 over 2 for today. And last one from this slide. Brian is working during an 8-hour shift, period. Okay, I only see one number, so I'm going to keep reading to see what else information I'm given. He's able to sort 3/4 of a barrel of recycling, 1/4 of an hour. 2 numbers, same sentence, and my units are different. So boom, right there, a ticket and a ratio. How many barrels? I don't know. Could he do it in an 8-hour shift? Again, these are the same 8 hours. I'm not using it twice because they're just repeating information. From there, again, barrels of recycling to hours would be my ticket. Barrels over hours. How many barrels? 3/4. How many hours did it take them? 1/4. Then again, it says 8 hours. So again, off to the side, I look at my ticket. I have my hours in my denominator, so that 8 or 8 over 1 is going to go in my denominator. Again, I do not know how many barrels that will be. From there, cross multiply. 1/4 times x, 1/4 x. This, again, needs to get shown off to the side. So it's 3 over 4 times 8 over 1. 3 times 8, 24. 4 times 1 is 4. That is what 1/4 times x equals. Again, you've got to show that work so that you know how to set up the problem. From there, we're going to divide each side by 1/4. One side cancels out. The other side's my division problem. 24 over 4 divided by 1/4. Keep, change, flip. 24 over 4 times 4 over 1. Again, don't be afraid to show 24 over 4 off to the side. You should get 96 over 4. We do not have to reduce that. So again, taking your time, organizing your work, show all the work, and these are not difficult problems. All right, moving forward, we're going to get into some scale factor problems. Now, the good thing about scale factor is that you solve them the exact same way you do unit rate and proportions. The only difference is how that information is going to be presented to you. So, on a blueprint, a wall measures 3.5 inches tall. Again, this number 3.5 is all by itself in its problem. So I'm not going to start there. Keep reading. The scale used to create the blueprint is 1/2 inches is the same as 2 feet. How tall is the wall in reality in feet? Again, these problems are basically saying something worth this much on a piece of paper that represents a model or a blueprint or a map is really this much in real life. So we're comparing 2 different units of measurement, inches and feet. You always start with the scale as your ratio. It's your ticket, it's your given numbers to stack. So in this problem, it doesn't matter where the scale is. That's what you start with. This one, it's in the middle of the problem. It could be in the beginning, at the end. It could be some kind of picture with the scale off to the side. You always start by locating the scale. It gives you your ticket. You're comparing inches that are equal to feet. Inches are feet, so inches over feet. It gives you your given ratio, 1/2 over 2. They're saying 1/2 is really 2. Then, that 3 1/2, it's all by itself. It goes with the variable side. Now, a couple things you need to consider. First off, still converting. 3 times 2 is 6, plus 1 is 7, all over 2. Now, you have to look and see where this is. This is 3 1/2 inches. I have my inches on top in my numerator, so that is why I put 7 over 2 in the top over x, because we don't know how many feet that is in reality. We know how big it is on the blueprint. We don't know how big it is in the real world. Once you have the problem set up, this is why they're really the same exact type of problem as a unit rate or a proportion problem. Cross multiply and solve for your variable. So 1/2 times x, easy, it's 1/2 x. Again, when you do this side, you're gonna have to show the work off to the side. 2 times 7 over 2, 2 times 7 is 14, 1 times 2 is 2. Again, I'm taking that and plugging it into my equation to solve for it. So the real problem was 1/2 times x equals 14 over 2. From there, just like every other ticket problem, I'm going to start isolating by dividing by my coefficient. One side cancels, the other side's my division problem. Top divided by bottom, 14 over 2 divided by 1/2. Keep it, change it, flip it. And again, top times top, bottom times top, bottom. 14 times 2 is 28. 2 times 1 is 2. And again, yes, this could be an answer, or since it's an easy division problem, 28 divided by 2, I did show you that it's really 14 feet. Okay? So again, same as a ticket problem, you're just using the scale. Use the scale first. Always locate the two numbers that are in the same sentence together. It's your ticket, it's your ratio, it's more than half of the problem. Second one. Okay, again, read carefully till you find a scale. A clockmaker makes 6 hours, or works for 6 hours. Again, this is all by itself in the problem. That's not the scale. That's just a scenario. It's trying to tell me something. During the shift, he can create 1/3 of a clock in 1/4 of an hour. Right there, that is my scale. The two numbers in the same sentence, they go together, they make a ratio, they make a ticket, they are trying to help you out. And then it says, how many clocks could he do in 6 hours? Again, just like some of those problems, they're repeating information, so be careful. Again, I'm going to start with where the problem tells me. Clocks to hours, same sentence, it's your ticket. Clocks over hours. How many clocks? 1/3. How many of an hour? 1/4. So 1/3 clock, 1/4 of an hour. Then again, if I keep reading, it says 6 hours. My hours are in my denominator, and I made everything in proper fractions. Once you have the problem set up, you cross multiply, start solving for your variable. Again, 1/3 times 6, you're going to have to do it off to the side. 1/3 times 6 over 1 is 6 over 3 or 2. But again, without a calculator, I would just leave things alone. 1/4 times x is 1/4 x. From there, divide each side by 1/4 to isolate x. One side cancels, the other side's your division problem. 6 over 3 divided by 1/4. Keep, change, flip. And you get 6 times 4 is 24. You get 1 times 3 is 3. So either 24 over 3, but again, 24 divided by 3 is 8. So it's 8 clocks in 6 hours. Again, probably you can just leave your answer alone, but A, B, C, D answers, you do have to be fluent in going back and forth between improper fractions, whole numbers, mixed numbers, those sorts of things. From there, you have your other bit.ly, so when you're done, raise your hand, make sure you have your warm-up, the notes, and the extra bit.ly at the end all finished.